Happy math class, everyone. I'm sorry I'm not here with you today. What I need you to do is to pause this video after you have your classwork notebook out and ready and your pencil ready. Come back to me when you have written down 3.3.1, how can I divide fractions? So the instructions here say today we will work on two methods for dividing fractions, and that is exactly what we're going to do. However, I'm going to show you at the end of the video a third method that I use. It's kind of a cheat method, and you get to choose which method you like best. So here we go. Our learning target for the day is simply I can divide fractions. Our first method today is called Madison's method. It's going to use the skill of finding the common denominator of two fractions in order to divide the two fractions. Now, finding common denominators is something you should be familiar with. You use common denominators when you add fractions and when you subtract fractions. So this uses a lot of prior knowledge and should feel pretty comfortable to you. So Madison's method takes the process of adding fractions, subtracting fractions, uses that common denominator method, and puts it into the division. So let's look at what that actually means. All of these steps are a lot. I do not expect you to write them down. I will have a PDF for you tomorrow that you can put all this information in. So the steps are 1 through 5, and on the next page we are going to go through them. So what I would like for you today to do, please, right now, if you can, is please write down this problem in your classwork notebooks. 1 3/8 divided by 3/4. Okay, let's get started. So the first thing that I want to point out is that our first fraction is a mixed number, 1 3/8. So if you remember correctly, when we have a mixed number, 1 3/8, we have to go around the world and we have to reduce that, or simplify it rather, so that it turns into an improper fraction. So the first thing we're going to do is 8 times 1, which is 8, and then we're going to add 3 to that to get 11. So our new fraction is going to become 11 all over 8. And that's going to be divided by the old fraction up on the top, which is 3/4. So the next question says, what is the common denominator? So if you're thinking about a common denominator, you are thinking about the two numbers on the bottom, this 8 and 4, and how can we get them to match? That's what we are trying to figure out. How can we get the denominators to match? So what you want to think about is if you look at the bigger number, which is the 8, and then we look at the 4 over here on the second one, how can we get this 4 to equal the 8? Well, hopefully you remember if we take 4 times 2, that will equal 8. So our common denominator is going to be, in this case, 8. And we want to only change this second fraction right here, this 3/4. So if we come back up here to step number 3, we have this fraction 3/4. And we know we need to multiply the bottom by 2 in order to get 8. But remember, 2 over 2, right, that equals 1, right? So what we want to do is multiply the top also, so that gives us a new fraction of 6/8. So if I write down our two fractions, if I have our 11 over 8, and that's going to be divided by our new fraction of 6 over 8, now we have our problem. So step number 4 says, make a new fraction out of the new numerators. So we're going to take the first numerator, which is 11, and we're going to put it over the second one, and that is 6, and that's your answer. So the last step, step number 5, says to simplify if you can. So 6 goes into 11 one time, and you have 5 out of 6 left over. And that is your solution. So what do you think of Madison's method? So what I'd like you to do is to try using Madison's method on this problem. So pause it, come back, and then I'm going to go through everything with you. Okay, so welcome back. So what we're going to do, the first thing we're going to do is we're going to look at our two denominators, the 8 and the 2, and we want to find a common denominator. So if we look at 8 and we look at 2, we know that if we take 2 and we multiply that by 4, that's going to give us 8. So we're going to be changing the second fraction. So if I take 1/2 and I multiply that by 4 over 4, which is equal to 1, I haven't changed the value. I'm just getting a new fraction. So it becomes 4/8. So that is my new fraction that I'm going to be using. So here are my two fractions, 7/8, which is the original fraction, and we are dividing that 7/8 by this new fraction here that we made, 4/8. So remember, the two denominators are the same, so we are going to kind of discard them, and our new fraction is going to be the numerator of the first fraction, which is 7, over top of the numerator of the second, which is 4. And then if you want to take that and reduce it a little bit, 4 goes into 7 one time, and there would be 3 out of 4 left over. So that would be our solutions. So our next thing that we're going to take a look at is Huey, and he uses the idea of the supergiant 1. And this is something that we worked on when we did reciprocals yesterday. It's also information that will help you when you get into 8th grade, but it is a little bit more complicated. Go ahead and read this slide and then scoot forward when you're ready. Again, here are all the steps necessary to do the division of fractions using Huey's method. I am going to put this out as a PDF, so please don't write them down. You can just peruse them a little bit, and we will go through everything on the next slide. So here is the next slide. There's a lot of information on here. I have it all written down, so I'm just going to kind of go through it with you. If you take a look, here is our very first fraction, just like before. It's the same fraction, right? You will notice that the first thing we did was take that and convert it, just like we did for Madison's method. So you always want to do that. It's kind of consistent. But before we kind of talk about this, I want to talk about what happened here. What we did was we took the first fraction, this one, right here, and the second fraction, and we made them into a big fraction. So we end up with a fraction over a fraction over a fraction, which in the math world is not allowed. Hence the reason why we need to use the big giant 1 to get rid of this fraction on the bottom. So step number 3 talks about making a giant 1 using the reciprocal of the denominator. We talked about the reciprocal yesterday. So this is the denominator fraction. So the reciprocal of that is 4/3. And we have to multiply the top and the bottom by 4/3. This is the big giant 1 right here. When you do that multiplication, these two cancel out, and you end up with a 1. And then what you're doing is you're multiplying 11/8 times 4/3. And that is giving you 44/24. The bad thing about Huey's method is you do end up with these big fractions, which are a little bit harder to simplify. But you can see, as you simplify, you get to the right answer. And this, in fact, gives you the exact same answer that we got using Madison's method. So what do you think of Huey's method? So we did this problem using Madison's method, and now I'm going to show you how to do the exact same problem using Huey's method. So the first thing that you want to do is take fraction 1 and put it over top of fraction 2. So that is 7/8. And that's going to be divided by 1/2. Then what we want to do is we want to multiply by the reciprocal on each one. That's not going to work. Let's use red. We want to multiply by the reciprocal. So that's going to be 2/1 and then 2/1. And that indeed would make a big giant 1. These are going to cross out, and what you're going to be left with is 7/8 times 2/1, which gives you 14/8, which gives you 1 6/8, which ends up giving you 1 3/4. So again, just like I said before, the problem with Huey's is that you end up with these bigger numbers, right, that you end up having to continue to reduce. So may not be for everyone, but it's a great idea. So to close out the division of fractions, I will give you an exit ticket. That is not true. What I'm going to do is give you an additional page here where I'm going to show you how to do something else. I'm going to show you how to do the two fractions that we worked on using our new method that I'm going to teach you right now. Okay? Okay, so this is a little interesting. This is the only way I could figure out how to add a page. So what we're going to do right now is I am going to rewrite this problem. I'm going to rewrite 7/8 over 1/2. 7/8 divided by 1/2. So this method is called the keep, change, flip method. I like to refer to it as Kentucky Fried Chicken spelled wrong. So what we want to do is we want to keep, this is our keep, so we're going to keep that. We are going to change the division to a multiplication, and we are going to flip that using the reciprocal, 2 over 1. And then we multiply straight across. 7 times 2 is 14 over 8, and that gives us, again, 1 over 6/8, which is 1 over 3/4. Way, way easier. So I'm going to do a second one. I'm going to just kind of block off a little bit of space here with a second fraction. And I'm just going to make up one. Let's do 3/4 divided by 2/5. Okay? And we're going to use the keep, change, flip. So what we want to do is we want to keep 3/4. We want to change the division to multiplication, and then we want to flip the other fraction using the reciprocal, 5 over 2. That's going to be 15 over 8. Oh, that's so similar to the other one that we just did. Excuse me, that's going to be 1 7/8. And that's how you do keep, change, flip. Okay, so you can do this one any way you would like. You can pause the video, you can try Madison's method, you can try Huey's method, and you can try keep, change, flip. Whichever method you want to do, you are first going to have to do around the world. So let's do that together before you pause the video. You're going to do 2 times 8, which is 16, plus 1, which is 17. Excuse me. So that's going to end up being 17 over 8 divided by 1/3. So you can pause this video and then come back. I'm going to do the keep, change, flip in black. So if I'm going to keep it, it's going to be 17 over 8. I'm going to change it, and then I'm going to flip it. 3 over 1. Whoops. Erase that. 3 over 1. I'm going to multiply. My denominator is 8. 3 times 7 is 21. Carry the 2, 51 over 8. You could leave it like that, but you really do want to reduce it. In order to reduce it, 8 goes into 51 6 times. And then what is going to be left? That would be 48, 49, 50, 51, 6 3/8. So that would be your solution there. I'll do Madison's method over here. Again, we know we have 17 over 8 divided by 1 over 3. We are looking for our common denominator. In this case, it's going to be 24. So we're going to have to figure out how do we get to 24 from 8. We want to multiply by 3 to get us 24 on the bottom. I'm going to erase that because I don't think that's great. We want this to be a common denominator of 24. So we want that to be 24. So we're going to have to change both fractions. So we're going to have to take 17 over 8, and we're going to multiply by 3 over 3, which is going to give us 24, and it's going to give us 51 on the top. And then we're going to take the second fraction, and we're going to need to, again, take 1/3, and we're going to need to multiply that by 8 over 8 to give us 8 over 24. So then we're going to take our two new fractions, which is going to be 51 over 24 divided by 8 over 24. And you can see that gets us the same result that the keep, change, flip. It just took us way less time to get there with keep, change, flip. So it's 51 over 8. And you know that when we reduce that, we end up with 6 3/8. Lastly, I will do Hugh's method. If I can find a different color, and I don't know where my, color scheme is, and I don't know what I just did there. Let's see if I can get it back. Okay. I guess I don't think I can use yellow. Nope, I'm not really sure how to get different colors. So I will use pure red for this time, and this one will be Huey's method. Okay, so what I want to do is, again, I have the same around the world, so I end up with 17 over 8, and that's going to be divided by 1/3. So I want to make the new fraction of 17 over 8 and 1/3. I'm going to multiply by the reciprocal, which is 3 over 1, and 3 over 1, and that's my big giant 1 here. a little messy. That means these go away, and I end up with 17 over 8 times 3 over 1, which you can see is where you end up after the keep change flip, just less work again. You end up with 51 over 8, which we know simplifies to 6 over 3/8. So I think the point of showing you all three methods is that the keep change flip is just the faster way through, but all methods involve getting to the same 17 over 8 times 3 over 1. So hopefully that makes sense. We'll see. Lastly, I need you to please go into Canvas and work on problem 94. The homework asks you to try each one of the methods. I'm going to let you try and use any method you want. You do not have to use Madison, and you do not have to use Huey, and you do not have to use keep change flip. And that's all I've got. Have a great rest of your day.